Okay. Hope you cannot hear me. There is a problem. There's an issue, a technical problem here. But I think it's now sorted. Hope you cannot hear me.
Mr. Theuri,
Yes, sir.
I can now hear you.
Yeah, thank you. Yeah, I had
Mr.
a problem.
Theuri?
Yes.
Mr. Theuri,
Yes, I can hear you.
the students are muted, so they cannot respond.
Yeah.
Okay, now proceed.
Now, I'm very happy that the problem has been sorted. The
Thank you.
technical
Proceed.
problem here, but we can now proceed.
Okay.
Yeah. Thank you. Okay, so we can start off. The issue. So, if I come to this example that I've just given here, these are rows: row 1, row 2, this column 1, column 2, column 3. column 3, sorry. So column 3, I can write C3. So therefore, if I'm to give the type matrix, the order of this matrix to the rows, I have 2, so it should be, 2 by 3. The things we have 2 rows and 3 columns. That's why I'm calling it 2 by 3 matrix. I hope I've started flowing now. I started flowing. The lesson is flowing well. So we have types of maths. We have if we are given that kind of an order, we can simply be able to interpret, or we can be able to explain what is happening there. Now the other thing is how to operate matrices, operations of matrices. Operations of matrices. Which operations do we have in matrices? We have addition, subtraction, and multiplication. So we start by adding addition. I hope I'm clear. So if we add matrices like A, B, C, D, you're adding another matrix like E, F, H. Ensure that you are connecting like row 1, column 1. Somebody is raising the hand. So if we are told to add this kind of matrix, we can add this. Can unmute.
Mr. Theuri.
Yes.
Mr. Theuri.
Yes.
This is Mr. Oboge.
Yeah, I can hear you.
The students are saying that they have not seen what you are displaying.
Oh, the video is not clear.
No,
what about?
They are unable to see the screen sharing.
Oh, yeah. Screen sharing.
Yes.
They are supposed to use I'm using the video.
Okay.
I'm using at where my photo, my video is. That's where my screen is.
Okay.
Is it clear now? Is it clear now?
Probably you can unmute. Mwalimu.
Yes.
Kindly unmute them to get the feedback, then you mute them again.
Oh, yeah. Let me do that. Okay. Okay. So, okay, who is having an issue? I can get it from somebody.
We can't see.
We can't see. There's nothing. We can't see. We can't see.
We can see.
What is clear?
We cannot see the screen.
We cannot. There's nothing. There is no video.
We can't see clearly.
There's nothing.
We can't see
the
video.
We can't see anything.
The video is not clear.
We can't see
I can't
the
see.
video.
There's
Okay, can you see
nothing.
me?
Totally can't.
Yes.
You can see me.
No. Yes.
No.
We can't see you.
Yes, you can see. And now, if I turn my camera to face my book. Can you see it now?
No.
No, not that.
Yes.
Yes.
We can see, but it's not clear.
You can't see the book.
Black.
Yes.
We can't
We
see the
can
book.
see. We can see.
It's
See now.
not clear.
No, we can't.
Still not.
That's a minute, eh?
We can see,
We are
but
seeing
not clear.
nothing.
It's black.
We are seeing nothing.
Yes, we see nothing. Nothing, teacher.
Just a minute, eh?
Alexina.
No,
Can see.
no.
Nothing.
Is this clear?
Malemu, it has appeared, but it's blood. Eh?
Yeah. So, it's clear now.
Is that Theuri?
Yes.
It's blood.
Wow. Wow. Oh. What about now?
Same thing.
Same thing, even now.
Yes.
And now. Oh.
Same thing.
Yeah. Ooh. Nothing.
I can see from a distance operations of matrix. Is it
Matrices, yes. From a distance.
Yes.
What about now? It's clear.
It's blood.
Let me just put up my camera. And now?
The same thing, Malemu. Are you able to pause the recording?
Pause. Let me see. Yes.
Or I can do it from my end. Eh? Let me do it from my end.
I've done pausing, yeah?
Or you
I
pause
paused the record. The
recording.
Yes. Plus 6 2 0 5. So if I'm told to add those two matrices, I'll get 2 plus 6 to get 8. 3 plus 2 5. 1 plus 0 to get negative 1. Then 3 plus 5 to get 8. So that would be my new answer. So if I look at another one, example, like if I had 2, if I'm going to subtraction.
Stop.
So multiplication of matrix, multiplication. We are told to multiply matrices. We can be given a matrix like 6, 4, 3, 6 times 0, 4. So what we do, if we are told to multiply such a matrix, we multiply rows times columns. So 6 times 1 plus 4 times 0. Then we take the other number, again 6 times negative 3 plus 4 times 4. Again, down here we have negative 3 times 1 plus 6 times 0. So we have that, you can have that again. Then we have negative 3 times negative 3 plus 6 times 4, like that. So 6 times 1 is 6 plus 0 is 6. 6 times negative 3 is 6 times negative 3 is negative 18. Negative 18 plus 16, that is negative 2. So we'll have negative 2 there. So 3 times 3, negative 3 times negative 3 is 9. 9 plus 6 times 4 is 24. So 24 plus 9, that will be 33. So we'll be having 33 there. And so, okay, this 3 times 1, that is 3. Okay, here we'll be having 3 plus 0. So this will be 3. Then 33 on the other side, like this. So if I'm told to add, my answer will be it will be 6, negative 2, 3, and that's 3. 3 and negative 33, like that. So what I'll do, I'll get another example here that we can try to multiply. So I'm just hoping that things are getting better. Today we have a serious challenge, but I apologize for that. I'll give one example here for you to try to multiply. So can you kindly try to multiply this? Try to multiply this. Everyone to try and multiply this. So we are multiplying 2, 3, 1, 4 times 6, negative 2, 0, 1, like that. So can you please multiply this? Try to multiply this times this and see whether you'll get the answer. So it will be, I hope it's clear. I'm just hoping that it is clear this time around. But sorry for the challenge today. We have a challenge of that connection. And the display is having an issue today. So if I try to multiply because of time and you're not able to access the screen share properly, so I can quickly multiply for you so that we can go to another, we can try to cover something good. So these 2, if I multiply this, rows times columns, so it will be 2 times 6 plus 3 times 0. That part will be done. Row 1, column 1. That will be the answer for row 1, column 1. So row 1, column 2. Row 1, column 2 will be 2 times negative 2 plus times negative 2 plus 3 times 1 plus 3 times 1. Row 2, column 1. The answer for row 2, column 1 will be, I take the same, I multiply 2 times 6 plus 6 times 0. 2 times 6 plus 3 times 0, sorry, plus 3 times 0. You can see we are multiplying this times this like that. So these 2 will go with 6, 3 will go with 0. We go to row 2, column 2. It will be, I think you can do it again here afresh, just for the purpose of clarity. 2, 3, 1, 4 times 6, negative 2, 0, 1. I want to do it here so that it can be clear to everyone. So I'm picking this, we'll go with this. We need to achieve 1, column 1. So it will be 2 times 6 plus 3 times 0. That is what we are supposed to have. Then we go to the other one, row, we are still at row 1, column 2. It will be 2 times negative 2. I hope it's clear now. Times 3 plus 3 times 1. So it is 2 times negative 2 plus 3 times 1. So we are done with that part. We are done with the second other part there. So the other one is 1 times 6 plus 4 times 0. That is another one there. So 1 times 6 plus 4 times 0. So that is row 2, column 1. Row 2, column 2 will be 1 times negative 2, 1 times negative 2 plus 4 times 1, because this will come here. So it is 1 times negative 2 plus 4 times 1. I hope we are now flowing properly. So I'm just hoping that you can see from that side. I'm just hoping that we can see. So what we should do here in this case, this 2 times 6 will be 12. 12 plus 3 times 0 is 0. So the first part will be having 12. Again, 2 times negative 2 is 4, negative 4, sorry, and 3 times 1 is 3. Negative 4 plus 3 is 1. Negative 1 should be negative 1. 1 times 6 is 6 plus 4 times 0 is 0. So here you should have 6. 1 times negative 2 is negative 2 plus 4 times 1. So negative 2 plus 4 is 2. That should be 2. So our answer is here. It will be 12, negative 1, 6, and 2. That is what you should be having. That is what we should be having. Now, the other thing, if you are told to have, you are given, there are some things we need to know, there are some operations we need to have in matrix, after knowing how to multiply matrix, because that's the most important thing, multiplying, because all our applications, they revolve around multiplication of matrices. Because even our application, when you're told to solve a quadratic, two simultaneous equations, we need to have that skill of multiplying matrices. So you really need to do a lot of practice when it comes to multiplication of matrices. So there is what we are supposed to learn again, and we are supposed to understand how to get the determinant of a matrix. So we need to go direct to the determinant of a matrix. So determinant of a matrix. Determinant of a matrix, what you're supposed to have. So if you're told to have the determinant of a matrix, so determinants of a matrix, we need to understand how to get the determinant. If you are given a matrix like 5, 9, -1, 2, and you are expected to get the determinant of that matrix. So what you should do, what you're supposed to do is you're given that. So what there are two things you need to know when you're given that matrix. The first step, when you're told to get the determinant, the first step is to multiply like 5 times 2, 5. You start with the right hand side like this, because some people confuse this. So it should be 5 times 2 minus the other side, like this side. Determinant, that is minus 9 times 1. So in this particular case, you need to be very sensitive with the minus. So if a minus appears twice, you are supposed to know what to do. Because when you have a minus 2 times, you expect that minus to disappear and to change to a positive. Therefore, what you need to know is that when we multiply 5 times 2, it should be 10 minus 9 to get 10 plus 9, which is equal to 19. So the answer there in that particular case will be 19. Will be 19. So if you're given, just to interpret that, there are 2 types of diagonals that you're supposed to have. So we have the principal diagonal or the main diagonal of the matrix. Like if you are given A, B, C, D. So this should be our main diagonal here. This is our main diagonal. Main diagonal. That is what we should be having. Our main diagonal is what we should start with. We should start from the main or the principal diagonal. We can also call it principal diagonal. Principal diagonal. So if you are told the principal diagonal is the one that you should start with always when you are getting the determinant of a matrix. So ensure that you cross like that, starting from the principal and the determinant of a matrix. So if you know how to get the inverse of the, so because immediately after get the determinant of a matrix, we go to the inverse of a matrix. So how do you get the inverse of a matrix? Because I'll take you through a very little time because the challenges you have gone through. Hope you understand. There are so many challenges today. Other lessons have been good, so I hope. But you have been very patient with that, with the lesson. You still learn despite the challenges. So here we have the main diagonal. Here is the one that
Excuse me, teacher, but you muted yourself and you can't hear anything. Teacher, would you please unmute yourself? We can't hear anything that you say.
Okay. So.
Thank you.
So I don't know. There's a problem of muting itself. I think there's a problem in the menu. But now let's try to this. Let's try to get the inverse of this. Find the inverse. But I'm hoping you can you see what I'm writing? Yeah? Can you see? So find the inverse. The inverse. Find the inverse. Find the inverse. Here is the inverse. Okay, you're supposed to find the inverse of this 3, 1, 6, 2. Find the inverse. Can you try to find the inverse? Try to find the inverse of that. Find the inverse of that. One of these, you should get 3 times 2 minus, you get the determinant, minus 3 times 2 minus 6 times 1. So the determinant is 0. What do we call that matrix? If the determinant is 0, because it's 6 times 2 is 6 minus 6 to get 0. So what do we call that when the determinant of a matrix is 0? Somebody? When the determinant is 0, what do we call that type of a matrix?
Mr. Theuri.
Yes?
You know the students are muted. They are unable to respond. Eh?
Yeah.
They are muted.
They're supposed to raise up the hand.
Okay, okay.
So that I can unmute the ones who are raising up the hand.
Okay, okay.
Okay. So, okay, Josephat Waithaka, I can see. You have raised up your hand.
Yeah, it's singular matrix.
It's called a singular matrix. Very good. It's called a singular matrix. So a singular matrix, if you find that the determinant is 0, that should be a singular matrix. So that's something you should know. So anytime you find the determinant of a matrix giving you a 0, you should understand that that's the type of a matrix called singular matrix. So I want to give you a different one so that you can find the inverse. So I will give you this 5, 3, find the inverse of this. 5, 3, 5, 7, 2, and 3. 5, 7, 2, 3, like that. 5, 7, 2, 3. So I want you to try that. You get the inverse. And remember, when you are getting the inverse, there are 2 steps. Step 1 is getting the determinant first. Once you get the determinant, you go to the next step of getting the inverse. You rearrange the principal axis. You rearrange the principal axis. You rearrange the principal axis, and you subtract from the other axis, from the diagonal, the principal diagonal, you subtract from the main diagonal. So I hope you're doing that. I've given you enough minutes, so I can quickly solve it because of time. So it will be 5 times 3 minus 2 times 7. So the determinant in this particular case, it will be 5 times 3 minus 14. So the determinant will be 1. So it will be 1 over 1, which is 1. Of course, it will be 1 into 5. Remember what we said about the principal diagonal. What do you do to the principal diagonal? So you interchange the principal diagonal. So it will be 1 into 5, 3. What do you do to the other diagonal? You change the sign. So it will be minus 7, minus 2, like that. So automatically this becomes our answer. So this becomes our answer. So that concept is applied. I wanted to go direct to how do we apply that topic. We need that concept. I want us to go direct to how you are supposed to apply that. You can apply that concept in solving simultaneous equation because that is the main idea or the main concept here. So the main concept is how to solve this using, you can be able to solve simultaneous equations using what we call matrix method. So I want us to solve that. That is why I want us to measure in for the few remaining minutes. So that if you achieve that, you'll have achieved everything despite the challenges we have gone through. So these two, so use matrix method. So you can write that. Use matrix method. I hope the minutes will be enough for us. Use matrix method. Matrix method to solve the following simultaneous equations, or just to solve. Use matrix method to solve this. How do you use matrix method to solve this? So use matrix method like this. I want to write the first example here. This is 2x plus 3y is equal to 7. That is my first example. Example 2x plus 2y is equal to 3. How do you use matrix method to solve that? Or how can I solve this using matrix method? So the first thing is to rearrange this equation to look like a matrix. Therefore, I'll pick 2 and 3 separately. 1, of course, when you have x, it means that we have 1x. So on the place of x, we are supposed to write 1. Here we have 2. So this is the way we are supposed to arrange it. It's supposed to be 2, 3, 1, 2, like that. We close that bracket. Then we write xy to get to 7, 3. So that's our first step. Our first step was supposed to know how to arrange our matrix to look like a what? We're supposed to arrange our matrix in that form, or our simultaneous equation to look like a matrix. So the next step is, so our next step, we are supposed to make sure that this matrix, we get the determinant. Then when we multiply the determinant with the matrix, you know that we should get a matrix. Okay, we are going to get that here. As you know, we're supposed to get a singular matrix. Like this is what I'm supposed to do. The first step is to get the determinant of this matrix. How do I get the determinant of this matrix? Determinant of this matrix will be 2 times 2 minus 1 times 3. So the determinant will be 2 times 2, it will be 4 minus 3 to get 1. So our determinant is 1. So the next step, as I've just said, you get the determinant. The inverse now from the determinant. After determinant, remember we said the next step is supposed to be getting the inverse. So let's write the inverse of this. The inverse will be 1 over 1, which is also, or is supposed to be 1, into the inverse. Of course, you are supposed to write the whole thing, the whole inverse, which is, we remember our principal diagonal is supposed to be interchanged. So it will be 2, because both are 2, they remain to be 2. Then we change the sign minus 3, sorry, and minus 1. We change the sign on the other diagonal. Then we write the original matrix, which is 2, 3, 1, 2. Then we write our xy should be equal to, remember to look here. We have, this is our original question here. We don't change the question. We introduce the inverse here and the inverse here. right? So in this part, we write the whole inverse the way it is, and the other part, we write the inverse. So there is no changing of the question. We just multiply by the inverse on both sides. It's just like multiplying the two sides of an equation by 3. You multiply this side, the right-hand side of the equation by 3. You multiply the left-hand side of the equation by 3. So you have not changed the equation. So we multiply by the inverse on the left-hand side and also multiply by the inverse in the right-hand side. So on both sides. So that's what I'm doing right now. So this is the inverse. So the inverse I've written there, I should also write it on the other side, which is 1 into, although you don't have to keep writing 1, 1, 1. This is 2, 1, 2, 2, then negative 3, negative 1. We open with what was there? 7 and 3. 7 and 3 has not changed. It was still there. Remember, this is what you're having originally here. This is what was there originally. So we have introduced inverse on both sides of the equation. So quickly, there's something you're supposed to understand in matrix. So inverse times the matrix. What do you get? You get that matrix again. You get that okay, you get a matrix which looks like this 1, 0, 0, 1. So if I multiply the whole of this, I should get 1, 0, 0, 1. So what do you do when you're solving a question? The whole of this part from here becomes 1, 0, 0, 1. So anytime you are in an exam, you're supposed to write this 1, 0, 0, 1. So the only part you'll struggle to multiply, of course, you're not actually supposed to struggle. You're just supposed to solve it comfortably. You know how to multiply matrices. Of course, you know how to multiply. So you just multiply this. You know how you multiply rows times columns. So it will be 2 times 7 plus negative 3 times 3. You know that. Sorry, we close that bracket properly. So there's another one, negative 1 times 7. Remember, this will go with what? When you're multiplying, 2 will go with 7, negative 3 will go with negative 3. Negative 1 will go with 7 again. 2 will go to 3 here. So it will be plus 2 times 3. We close that, the whole of that. There's an equal sign here. Right? I'll do another one, a quick one. So let me just finish this. In case there's somebody who has not understood, I'll solve another example. So anytime you multiply by this, what are you supposed to get? 1 times x, you'll get x. Then plus 0, it will remain to be x. The other one will be 1 times 0 times x will be 0, y. So we'll be having x, y. So here, allow me to use this. I write it here. Allow me to write it at this corner. So it will be xy. X will be equal to what? And y will be equal to what? So this is 2 times 7 is 14. 9 is 14 minus 9 to get 5. Automatically, x becomes 5. Another one. Negative 1 times 7 is negative 7. Negative 2 times 3. What is negative? So it was negative, it was 2, sorry. It was 2 times 3, 6. What is negative 7 plus 6? It will be negative 1. So y is negative 1. So you are done. We solve the simultaneous equation. That's how simple it is. Just in case somebody was not understood, I'll pick another one and solve it very fast before time elapses. I hope you're learning something. I hope you're understanding that properly. So I understand that every class had covered this before we went home. So I know you are able to cope up with that speed. I'm forced to rush because of the time lost. We have actually lost a lot of time trying to connect or to address that issue. So here, example 2. I want to write a question, then I will move a bit slow so that I can now allow everyone to move with me. So try to solve yours as I solve this. So we try to move together in each step. So 3x minus 4y is equal to 7. 4x plus 6y is equal to 15. So that is the question. 3x, I won't repeat in case there's somebody who is not seeing it properly. It's supposed to be 3x minus 4y equal to 7. 4x plus 6y is equal to 15. Is equal to 15. Is equal to 15. So 3x minus 4y is equal to 7. 3x minus 4y is equal to 7. 4x plus 6y is equal to 15. So can I allow you to move just one step ahead of me? I want to follow you because I want to believe that everyone is understanding the concept. So the first step is to rearrange this to appear like a what? It should appear like a what? Like a matrix. So it should be 3, negative 4, then 4, 6, x, so 3, negative 4, yes, and 3, negative 4, then 4 and 6, and then we write x, y should be equal to 7 and 15. Equal so? So step 2, determinant. So determinant, unaandika hapo determinant. Determinant will be 3 times 6 minus 4 times minus 4. So this will be 3 times 6 is 18 minus 16. 3 times 8 is 3 times 6 is 18 minus 16. So it will be 18 plus 16 because of minus. So this will be 34, correct? It should be 34. So the determinant is 34. So remember what I said, it is so easy to solve this simultaneous equation using the matrix method because I said that you introduce inverse on both sides of the equation. Introduce inverse on both sides of the equation. And I've taken you through through the process of getting the inverse. By first of all getting the determinant, so you can simply do the inverse here. You can get the inverse of that matrix at this point. So it will be 1 over determinant 34 into 1 over 34 into what? 1 over 34 into, remember the principal diagonal is the one that we interchange. So it will be 6, 3. Then we change the signs on the other diagonal, which is 4. Remember, there is a negative 4 here. So when you put a negative here, it changes to a plus, then negative 4. Because there is no negative, it will become 4. So that's the inverse. This is introduced of the equation. Simple, you're done. And again, I will show you another shortcut of how you're supposed to solve the left-hand side of the equation. Actually, we have done it in the other example. So it should be, introduce the same on both sides of the equation. So it will be 1 over 34 into 6, 4, negative 4, 3. That is the inverse. I'm introducing it on the left-hand side. So I'll write the original. This is what we had before. So we repeat the same. 3, negative 4, 4, 6, x, y. I just write it quickly because it was there. Then, what have I said? What you have done on the left-hand side, you do the same on the right-hand side. So this is how you do it. 1 over 34 into 6, 4, negative 4, 3. Then, what was I having before there? I was having 7 and 15. 7, 15, like that. Shortcut here, it is allowed everywhere, even in the exam, you can do the same. We know that when you multiply an inverse by the original matrix, we get this. We get 1, 0, 0, 1. You don't have to show all the working for this part. It is known. It is very automatic that when you multiply the inverse by the original matrix, you get this 1, 0, 0, 1. Yes, I think so. If you have a problem, you can raise up the hand. We can still address. So x, y was there, x, y remained there. So this is the only part we need to work on. So if you want to be safe, if you don't want to confuse this, the determinant should remain outside, because if you work with so many fractions, you might end up messing. So just let it stay there, 1/34. Then you first of all multiply whatever is inside. So it will be 6 times 7 plus 15 times 4. I'm 4 times 15. The lower side should be -4 times 7 plus 3 times 15. So it is rows times columns. So this is the first row multiplying by the column, which is 6 times 7. 6 will go with 7. I'm just emphasizing. And 4 will go with 15. When you go to the lower part, should be -4 times 7 plus 3 times 15. 3 times 15. So we open the bracket. Of course, this we said that this will become xy, because when you multiply 1 times x will be x, 0 will just go, and y will be left with y there. So do we open this? Is equal to 1/34. 6 times 7 is 42. 42. So we'll be having 42 plus 4 times 15 is 60. So this will be 102. So it will be 102. -4. Remember, we have -4 times 7 is -28 plus 3 times 15, 45. So it will be -28 plus 45. So it will be like 45 minus 28. So we'll be having what? So when you multiply 4, that is -28, 45. Yeah, exactly. So it will be 17. So it will be 17. So if there is any error, you can raise up your hand. We can correct. Is that what you're getting on that side? Anyone with a problem with that? Anyone with a problem? So I'm just hoping that you are getting the same answer, because you are, as I said, we are supposed to move together, or else you're supposed to be one step ahead of me so that I can follow for comparison purposes. So how do you get your value of x? So you open with this. You open each number. I don't know what you're getting on that side. So your x should be, your x is supposed to have, should be 102/34. You can try to simplify that. Then y should be 17/34. So check what you're having on that side, so that if there is any correction, we can do. So what did you get from that side, Alex? Alan Kariuki, what do you get from that side? Lewis?
X is equal to 3.
Okay, 3. What did you get here in this part? Just a minute. I wanted to get those. What did you get here? This part, when you multiply, multiplication. I also have Lewis trying to raise up the hand. Yeah. I wanted you to be very keen and tell me where you can have. What did you get this part of multiplication? What was your inverse?
An inverse was 1/34.
Good. It's okay. Into
6/4.
6/4.
-4 and 3.
-4 and 3.
Yes.
Good. So from there, after multiplying, remember you need to multiply this part with the inverse, right?
Yes.
So what did you get in this part, the inner part? You could be correct.
I took the matrix.
We took the matrix 6, 4, negative 4, 3.
What about that? Remember?
I multiplied it by
negative 4, 3. Serious? Yeah, that's okay. And then you open with what? 7 and 15. Did you do that?
First.
7 and 15.
Yes.
Victor, you want to say something? I want us to interact for a few minutes, so that you can at least you can have some little minutes to interact kidogo tuone. So what did you get in this part after multiplying? 6 by 7.
I got 1.
Can't hear you.
1 over 34 into 102, 17.
Good. 1 over 34 in 102, you get 17.
Yes.
Yeah. Iko sawa, which is okay. The lower part?
Then when I multiplied, I got 3.5.
3.5. This part, remember you are supposed to multiply 4 times negative 4 times 7. Did you do that? Plus?
Yes.
Plus 3 times 15. Did you do that? Ulifanya hivyo?
Yes.
Negative 4 times 17 ni nini? Negative 28, right?
Yes.
Plus, what is 3 times 15? 45.
Yes.
So after subtraction, what is minus 28 plus 45?
17.
17. Remember you had 1 over that 4 outside?
Yes.
So
yes.
Did you get this 102 and 17, and you still have 1 over 34? So you open 1 over 34 with the 102 and also with the 17. Did you do that?
Yes.
So that's what you're supposed to do. You're supposed to have 102 over 34 and also open with the same 17 over 34. So if there's a way you can simplify that. Anyone with an issue? You should interact for some time. Kidogo tu to interact kidogo. Najua tumekuwa na challenge mingi sana on the way. Although we had several good lessons before. So today is we accept. I apologize for the challenges, but I hope we'll get back to our normal way of doing things. My laptop has just developed some problems and I could not control. I had to get some options. Nimejaribu kutafuta plan B. Laptop yangu ime break down, although I'm going to address that issue. So that's why you have found me struggling to get plan B here and there. Lakini mwisho tumesoma. So I hope next time we'll get back to our original way of doing things, the way we normally do them, the way we share the screen, we interact like that. So leo nimejaribu kutafuta plan B. You can see the way I've gone so manual today. Leo tumefanya manual. Hata stima ikipotea unatafuta generator, sio? Anybody with something to add or a question to ask before we end our lesson? Anybody? You can raise up your hand if you have a problem. Remember, you have an assignment. We need to have an assignment. Ensure that you do this assignment. I know this might be a last lesson of so when you go to your KMF, remember that's the best now because it's accessible to everyone. That topic of matrix in Form 3. There are so many questions that are there and very nice ones. So go try those questions. So they will expose you to more and more questions, especially on solving simultaneous equations and doing some other things. So what do you think? You have a question? Anything you can add? Anyone with an issue? Anyone? So if there's no, yes?
I have an announcement.
Okay.
Thank you, Mr. Theuri, for the lesson. Good morning, students. Once again, I appreciate your commitment in the online learning. Want to inform you that we are coming to the end of our term this week on Friday, the 7th day of August, the year 2020. As we come to the end of the term, some classes have been requested to resend their examination to their respective teachers. Specifically, for now, I'm addressing Form 3P. You were guided by the format to resend your chemistry exam to Madam Violet Owino. Her contact and email address were provided. Remember, these exams are supposed to be remarked and report forms issued latest by Friday. I have just checked in the Zeraki system in Form 3P. Only 4 students have resent their chemistry work. Kindly, I'm appealing to you, at the end of your session with Mr. Theuri, make a point of resending your chemistry examination. Number 3, those of you take CRI.
Thank you, Mr. Boge.
I'm on.
So I hope every.
Mr. Theuri?
Yes.
One more. Those of you take CRI, remember yesterday you had one of your lessons postponed. It will take place today at 11. In fact, in the next 20 minutes. We want you to get prepared, get ready at exactly 11 a.m. Let's be in class for that CRA lesson. Thank you, and I wish you a good day.
Mm-hmm.